Peatlands are a type of wetland that cover 3% of our planet's surface. Intact peatlands fix carbon because the biomass grown each year is not completely decomposed due to waterlogging of the soil. In Scotland, 25% of our land area is covered by peatlands. Unfortunately, around 75% of Scotland's peatlands are degraded due to historic drainage, extraction and conversion to other land uses, and so they no longer work as the carbon sink they should be, and instead emit around 8 or 9 megatons of carbon dioxide equivalents per year. That is a staggering 15% or more of the total territorial emissions in Scotland. Although we now know how to re-wet our peatlands, by blocking up drainage ditches for example, investment in restoration has been tentative because of the perceived risk that re-wetting might not reduce greenhouse gas emissions. Scientists across the UK are carrying out research to better understand the scale of the emissions reductions that re-wetting efforts can bring, and the long-term resilience of restored peatlands to climate change. We would like to show you just 2 of 10 of these research locations across Scotland. This is a heavily eroded upland blanket bog in the Cairngorms National Park. Erosion affects 14% of our peatlands. Such eroded sites not only lose carbon in the form of greenhouse gas emissions directly, but also indirectly through the loss of peat into our waterways. We use equipment that can measure the exchange of greenhouse gases between the soil and the atmosphere across a large area of the landscape. This tower, for example, receives information from an area of around 500 square metres. In the Forcenard Flows National Nature Reserve, we have a network of 5 of these flux towers. Around 17% of our peatlands were drained in order to plant conifers, until it was realised that this destroyed breeding bird habitats alongside causing significant emissions from the peat. Restoration work at Forcenard has resulted in a much improved peatland habitat, with typical species gradually returning with time. This positive outcome is mirrored at many other restoration sites across Scotland. We are monitoring the emissions reductions to see whether different restoration techniques result in better outcomes and whether restoration efforts are future climate proof. Data from researchers around the UK and Europe, including from these research stations, has produced evidence that re-wetting reduces emissions. A peatland drained to an average annual water level of 1 metre will lose around 25 to 30 tonnes of carbon dioxide per year. For every 10 centimetres of bringing the water table closer to the surface, the emissions are reduced by at least 3 tonnes of carbon dioxide. Unfortunately, at some point, further re-wetting is partially offset by methane emissions, which increase in a non-linear way the wetter a peatland is. This means that there is a sweet spot where the balance is just right to produce a net carbon sink. It is this sweet spot that we need to aim for in restoration projects. To attract green finance in re-wetting as a nature-based solution to mitigate greenhouse gas emissions, we need to have confidence in the outcomes now and into the future. We can now say with confidence that by raising the water table, greenhouse gas emissions from peatlands are drastically reduced. Ongoing research will answer the question of the stability of these emissions reductions.